with Aryl halide chapter. This is the second lecture. So we stopped here in the reactivity of the halogen that be substituted on the cycle, on the aromatic cycle of the Aryl halide. So the order of leaving group reactivity in nucleophilic aromatic substitution, look, he said, is the opposite of that has seen if in the aliphatic substitution. What meaning that? Okay, in aliphatic substitution, if you have nucleophile, and this nucleophile, it would be attack alkyl halide. This is the alkyl halide, X. Okay, alkyl halide. Anyone, it will be the better one, or the better leaving group here at the X. It will be fluor, or chlor, or brom, or iod. And what? And SN2 reaction. Anyone, it will be the faster one. With the fluor substituted or with the iodine substituted? Why? Good leaving group. Because the iodine, which will leave the structure, it will be what? Iodine minus. And the fluor, it will be fluor minus. Anyone is the more stable one? The iodine. Why? Because the iodine? No, because yes, the size of the anion is the bigger size than the fluorine. Yes, the fluorine is high electronegativity atom, but the more stable one is the iodine. Okay, for this reason, the iodine, it will be the more stable one. That if I say to you, rank the halogen according to increasing the reactivity toward, or the alkyl halide toward SN2 reaction, here SN2 reaction, and what? In aliphatic substitution. Yani in aliphatic substitution, you will be said the iodine, and then brom, and then chlor, and then to the final, the fluor. Here in nucleophilic aromatic substitution, look, in nucleophilic, the situation, it will be what? Reverse. It will be opposite. Yani بالعكس. Okay, it will be the fluor, it will be the faster one. Look, 312. And the chlor, it will be slower than the fluor. And the brom, slower than the chlor, like that. Okay, that meaning the order, it will be for what? It will be reverse in the aromatic substitution. The fluor, and then chlor, and then brom, and then iodine. Why? Put mark a question here. Why? This is a question for you. Why? Do you have answer? Because the same, eh? Yes, because the electronegativity. Because the fluorine has higher electronegativity, okay, than iodine. We don't talk about the leaving group. We talk here about the intermediate product. So in nucleophilic aromatic substitution, the first step is what? Nucleophilic aromatic substitution. The first step is what? Is carb anion formation. Okay? Carb anion formation. So, this is the first step. Look. You have benzene, this, substituted with مثلا a fluor. Okay? Substituted with a fluor. And we have nucleophile. This nucleophile, it will be add. We have مثلا nitro group here, NO2. Nitro group here. If this nucleophile add to the same carbon that has the halogen, it will give you what? Give you an ion. Give you this. Minus. This the fluor, and this the nucleophile, and this the NO2. Okay. So you have carb anion, you have negative charge over all benzene ring. Anyone is more stable one. If you have a fluor or you have iodine. This is the iodine, nucleophile. Anyone is the more stable intermediate product. This or this? Fluor. Why? Because the fluor is higher electronegativity atom, withdraw the electron density from the benzene ring and increase the stability. Okay? And increase the stability. This is the answer. So, if you have like this reaction, look, para-nitrofluorine, this parafluoronitropenzene, this is the nitropenzene, react with potassium methoxide. Okay, look up. Potassium methoxide is base or acid? As you see, base, strong base, very strong base, because it's negatively charged. Okay, so the reaction, it will be happen and give you the product. So look to the product and the starting material. Look to the product and the starting material. What is the difference between the starting material and the product? What is the difference? Where is the difference? In nitro group? No. Where is the difference? Fluor replaced by OCH3. Fluor replaced by OCH3. That meaning is what? Substituent. Substituent. Okay? Substituent. Okay, now this is negatively charged. That meaning is nucleophilic substituent or electrophilic substituent? Nucleophilic substituent. Okay? Nucleophilic substituent. Now, the addition elimination mechanism of nucleophilic aromatic substitution, I will explain for you the mechanism now for this type of reaction. How the reaction, it will be happen by any way, by any mechanism. Okay? So, he said the generally accepted mechanism for the nucleophilic aromatic substitution and what? At nitro substituted aryl halide. Talaba, nitro substitute aryl halide, put 2 lines, 3 lines. This is important work. Okay? So, anytime, if I say to you, anytime the nucleophilic aromatic substitution mechanism, this is the mechanism, addition elimination mechanism, it will be happened anytime with any type of compound, with nitro substituted compound. Must be nitro. Okay? Must be nitro. Must be nitro substituted compound. So this is important. Some students will be ask me, say that anytime you will be used addition elimination, anytime you use elimination addition. This is the also important question. So with nitro substituted compound, the mechanism, it will be addition elimination. Okay, addition elimination. Okay, this is the addition elimination mechanism. Actually, we have the rate of reaction depended on the concentration of the aryl halide and the nucleophile, both of them. And if you increase the concentration of the aryl halide, the rate of reaction will be increased. If you increase the reaction of the, if you increase the concentration of the nucleophile, also the rate of reaction will be increased. That meaning, kinetically, the rate of reaction depended on both concentration of the aryl halide and what? The nucleophile. Okay? Both of them, it will be affect the rate of the reaction. Both of them. Okay. So, slightly. Yeah. So, the nucleophile addition step, the rate determination step for the aromatic characteristic ring, okay, must be, it will be, we will be lost the aromaticity of our system, okay? Aromaticity of our system and give you cyclohexadienal anion intermediate, as I explained for you here. Show you in the figure. Look, this is our reaction again. This is our reaction. Where is the difference between starting material and the product? The difference, this is replaced, fluor replaced by what? By OCH3. That meaning is nucleophilic aromatic substitution. So the step 1, addition step, the nucleophile in this step, it will be attack the carbon that has bear the what? The fluorine. Yes, the leaving group. And give you what? Give you carb anion. Give you carb anion. When this attack this carbon, this pi bond, it will be open. Why this pi bond will be open? Why? Why the pi bond will be open? Because what? Yes, to make the carbon ion. Why? Now, this carbon, how many bonds that has it? 1, 2, 3, 4. If you make a new bond here, the carbon, it will be 5 bond. Impossible 5 bond. Okay? The 5 bond is impossible. And this time, any bond, it will be open, the weaker bond. This sigma bond, and this pi bond. Pi bond is the weaker bond, it will be open, and to add to this carbon to give you negative charge on the carbon. This negative charge is cation or anion? Anion. Good, is anion. Then, look to the cycle is what? Cyclohexane diene. We have diene here. Okay? It will be cyclohexane dienyl. anion أو نبيه cyclohexane dinyl anion. تمام. Again cyclohexane dinyl anion. Di يعني two, dinyl anion يعني you have two double bond. Okay, good. Do you have a question? Do you have a question? No. So this is the first intermediate أول خطوة. The first step give you the first intermediate carbonyl dinyl. So carbonyl dinyl here, that it has resonance or there is no resonance here, and this is yes, has resonance, of course. This make double bond and this it will be open. When this negative charge directly bonded to the NO2, we have additional resonance structure, and the NO2 it will be increase the stability of the carb anion. Okay, carb anion. And this is your homework. I want from you to write the resonance structure for this product. Also, you have it maybe next slide. So this is the first step. This is the first step. Look to the second step. Second step is the elimination stage. That meaning in this step, the leaving group, it will be lost from the structure. Okay, the leaving group, it will be lost from the structure. For this reason, we said is elimination. Okay, elimination. So loss a halide the leaving group. Our leaving group is what? The halogen, fluor, chlor, brom, iode. Okay, so the elimination here, loss a halide from the cyclohexane dinyl intermediate. This is the cyclohexane dinyl anion. Okay, restore our aromatic system again. So in the first step, if you look to the first step, your aromatic system, it will be what? It will be lost. Here, no aromatic system, but your aromatic system, it will be come back again. It will be formed again. Okay? Your aromatic system, it will be formed again. So here in this step, he said, the aromaticity of the ring, it will be formed again. Okay? It will be come again. To give the product, to give you the product. This is the product. So what is how the leaving group it will be leave the structure? This is the shape of electron, make pi bond, okay, and the fluor, the leaving group, it will be leave the structure. This is the elimination step. Okay, the elimination step. Just this is the mechanism, two-step mechanism: addition, elimination, nothing else. Yeah. So he said, write the most stable resonance structure. What he said? Write the most stable. Nahami, not all the resonance structure. I want just the most stable. The most stable resonance structure for the cyclohexadinyl anion formed by the reaction of methoxide anion with orthofluoronitropenzene. Just I want the most stable one. So what you have to do, if you want, write the intermediate product. This is the intermediate product. Write all resonance structure and look to anyone is the more stable one. Anyone is the more stable one. So if you go to the next slide, this the carb anion. Okay, this is the carb anion. This. Now carb anion. I want to write the resonance structure now. Yes, carb anion make double bond, and this pi bond it will be open to this carbon. It will be give you another carb anion. This carb anion look directly bonded to the NO2, directly bonded to the nitrogen. Do you think can be this negative charge enter to the additional resonance structure? Do you think yes? Can be enter, can be make double bond, and this double bond it will be open to the oxygen to give you negative sir oxygen. Now anyone is the more stable one, negative sir carbon or negative sir oxygen? Yes, exactly. Negative on the oxygen atom is more stable from the negative on the carbon. Why? Yes, because because more electronegativity atom. Okay, because the more electronegativity atom for the halogen, for the nitrogen. If you compare the nitrogen electronegativity for the nitrogen, oxygen, sorry, and the carbon, the oxygen is more electronegativity. Tamam. So this is the answer. This. For this reason, the most stable resonance structure is this. This figure is the most stable resonance structure. Why? Because the negative charge, yes, on the oxygen atom. Tamam? Because the negative charge on the oxygen atom. Clear? Go to the next slide. So, if you have nitro group, look, if you have nitro group that substituted on meta, not orthopara. Orthopara we know is faster than meta. Why? Why? Because if the NO2 is substituted on meta, the resonance structure, look, this give you carbanion, make double bond, and the negative it will be go to this carbon, not in this carbon. So we don't have directly negative charge bonded to the NO2. So the negative charge here cannot be enter with resonance with the NO2. Okay? For this reason, diamond, ortho-para substitute with nitro group is faster than meta. Why? Because the meta, there is no resonance with the NO2. Okay? There is no resonance with the NO2. And give you just here negative on this carbon, negative on this carbon, negative on this carbon. What this position? Ortho position and meta position. Diamond, the negative charge, it will be on ortho and on para positions. Okay? There is no negative on meta position. Be careful, tamam? This for you. In your exam, when you write the answer, be careful. The negative charge diamond at ortho and para position. Ortho, para. There is no negative on meta. This meta or this meta. There is no negative on meta position. Tamam? So negative charge is stick to the carbon in or resonance form. The negative charge here over just carbon atom. There is no negative on the oxygen atom. Okay? Here, a nitro group is strongly activating substituent. Look, diamond, he said, is activating substituent in nucleophilic aromatic substituent, not in electrophilic. Electrophilic بالعكس. Nitro group, if you remember, in electrophilic substitution is what? Is deactivating group. Deactivating. But here in nucleophilic substitution, no. It will be activating group. يعني بالعكس reverse that has seen in electrophilic aromatic substitution. تمام? So, where is stabilize? What make in the nitro group? Diamond stabilize the carb anion. Stabilize the carb anion in intermediate products. Stabilize the carb anion. Okay? The work of the NO2 is what? Stabilize the carb anion. Chunko with the drawing group. Tamam? Okay, I know. You can open this window if you want. Now, not that part, just the window. Okay. Now the leaving group here, as we said before that, I said to you, put mark a question. Anyone is the more active one, the fluor or chloroprom or iode? Here, the fluor. Why? Botan. Why? Because the electronegativity. Yes. And this is the answer here. Look, leaving group is aryl fluoride have the strongest carbon halogen bond and the react faster in the rate determination step. Okay? Cannot be involved carbon hydrogen bond eclipse. For this reason, according to the mechanism, according to our mechanism, because we have addition, the second state is elimination. Okay? Is elimination. Usually the high reactive of aryl fluoride arises because the fluorine is the most potent electronegativity. Electronegativity of the halogen. So if you compare the stability of two components, where's here? يعني انه كتأثير فلوريد what is the effect of the fluorine? To increase the stability of the intermediate. So if you have two intermediate like this, negative with fluorine or negative iodine. Now, anyone is the more stable one? Fluor. Why? Yes, because the fluorine is high electronegativity atom. Okay, decrease the electron density here, decrease the electron density and make the fluorine more stable. More stable. Tamam? What? مساحة unstable. Tamam. Now, related nucleophilic aromatic substitution. Some electrophilic aromatic substitution actually happened without nitro group. Nitro group Nina, there is no nitro group substituent with nitro group. There is no nitro group over aromatic ring, but substitution can be happened just in a special reaction, not overall reaction. Here, So we say the related nucleophilic aromatic substitution reactions. Some reactions, I will give you 2 examples here maybe. The most common type of aryl halide in nucleophilic aromatic substitution, there are those, what has what? Orthopara nitrosubstituent. We know this, orthopara. But some classes of aryl halide like this, okay, a few reactions, few number of reactions can be entered to this type of nucleophilic aromatic substitution. Okay, one class include highly fluorinated aromatic compound like this. Look, all of them is substituted with what? With the fluor atom. So this also can be entered to the nucleophilic aromatic substitution. Why? Because the fluor is withdrawing, and increase the stability of the intermediate. Okay, and increase the stability of the intermediate. Okay. So which undergo substitution of just one fluorine atom, it will be replaced. Just one fluorine atom, it will be replaced by the nucleophile, and the other it will be remain without replacement. Okay, the substitution. So here, if we want to write the mechanism for this compound, what you have to do? First step, the OCH3 will be add and give you negative charge over benzene ring. This is the first step, okay? Yes, resonance, and then elimination. Good. So we have fluor. This is the fluor. Okay. Now, first step, the like this, OCH3 nucleophile, it will be add. Where is it? Anyone? This, no different. Okay, the same. I will add to here, and this, it will be opened to this carbon to give you the first anion. Yes, partial resonance, of course. Fluor, and we have here fluor anion OCH3 fluor. Okay, OCH3. Write additional resonance structure. طبعا this it will become to here, and this it will be up to give you the second resonance structure. This for you, and the third resonance structure. 3 resonance structure. Second step is lose the leaving group. Okay, how to lose the leaving group? This make pi bond, and this leave the structure to give you the final product. This, fluor, or CH. 2-step mechanism. Step number 1 and step number 2, and you have step number 1. We have resonance structure for carb anion. Okay, clear? What we have? Okay. Second type of some molecules can be entered to the nucleophilic also substitution is the heterocyclic compound that called pyridine. Look, without halogen is the pyridine cycle. This is the pyridine cycle. Okay, the pyridine cycle also can be entered to the nucleophilic aromatic substitution. If you compare the reactivity of 2-chloropyridine and the chloropenzene, 2-chloropyridine is billion faster than chloropenzene itself. So faster than chloropenzene itself. Okay, so here, why this can be also entered to the nucleophilic aromatic substitution? If you compare the first step to formation of the carb anion, the negative charge, it will be what? It will be on the nitrogen atom. Negative charge, it will be on the nitrogen atom. So nitrogen, we have a chlor. This is the compound. 2-chloropyridine. Why 2-chloro? 1, 2 2-chloropyridine. It will be react with O, CH3 with OR, for example, with OR. any strong nucleophile, the addition it will be happened. The addition it will be happened, and give you negative on the nitrogen. Give you this intermediate. Nitrogen, negative, and this we have chlor, OCH3 or OR. This is the intermediate. Where is the negative charge? On the nitrogen. If you compare this with the chloropenzene, and this chloropenzene, and this chloropenzene, it will be react with OCH3. طبعا there is no reaction, but for example, it will react with OCH3. Negative charge it will be on the carbon. Anyone is more stable, or negative charge on the carbon or on the nitrogen? بوتان أو شولاتا. تمام. On the nitrogen, because the nitrogen is high electronegativity atom than carbon. Increase the stability of what? Of the intermediate product during mechanism reaction. تمام? During mechanism reaction. Clear? Do you have a problem with this? No. So, homework, offer an explanation, give an explanation for the observation of the 4-chloropyridine is more reactive toward nucleophilic than 3-chloropyridine. Why? Why 4-chloropyridine is more reactive than 3-chloropyridine? This is for you, homework for you. Okay? But the idea here is more reactive for chloropyridine, also because the intermediate product, the negative charge is directly on the nitrogen atom, not like this compound. Here, there is no negative charge on the nitrogen atom for the intermediate product, for the resonance structure, okay? But here, yes, we will have negative charge on the nitrogen atom during our mechanism in intermediate products. It will be increase the stability. Another type of the nucleophilic aromatic substitution occur under quite different reaction condition. طبعا, from this it will be discussed here in this part. In the next part, the elimination addition mechanism of the nucleophilic aromatic substitution. This is the second type of our substitution here, is the elimination addition substitution. Look, firstly, look to this reaction. Chloropenzene. معنى chloropenzene? This is KNH2. تمام؟ amide. This يعني I mean very strong basis. Okay, very strong basis. So look the reaction. The reactions happened and give you product. Substitution is happened. Okay, we have replaced the chlor with what? With NH2. So how this reaction is happened without withdrawing group here? Withdrawing group. Do you found withdrawing group here? NO2. So there is no withdrawing group, but the reaction is happened. How the reaction is happened? أو إيك مشكلة? The first problem here. This is the first problem. There is no withdrawing group. So without withdrawing group, our mechanism elimination mechanism can be suitable here? No, not suitable. Why? Because the carb anion it will be not stable. Because the carb anion it will be not stable. This is the first problem. The second problem we found it here. Look to this reaction. If I give you this compound, orthobromotoluene, I say to you, this orthobromotoluene, it will be entered to the nucleophilic aromatic substitution. المفروض NH2 أبا NH2 معنا minus. المفروض NH2 it will be where? It will be replaced with CH3 with Br. Then the Br position is what? Located at position number 2. This 1, 2. Must be, if we talk about this mechanism, our mechanism is addition elimination mechanism, must be the NH2, it will be bonded just in the position number 2. But we found it 2 isomers product. We found it as replacement with number 2, and we found the second isomer. Replacement also substitution on number 3. So we have 2 products, not like this mechanism, just 1 product. Here we have 2 products. Also this is a problem. How this product, 2 product it will be formed. How this 2 isomers it will be formed. If we say addition elimination mechanism, that meaning give you just this. Okay? But here it is not addition elimination mechanism. Give you two isomers. Okay? One of them at the ortho substituent and the second meta substituent. Also, this is the second problem in this type of the reaction. Okay? How this reaction will be happened during what? By using any mechanism. Okay? So from this point, we go to find another explanation how this reaction will be happen. For a long time, look, for a long time, they just wanted to suggest a suitable mechanism for this type of the substitution. So, the regoselectivity of this reaction, it will be give you isomers, to give you the orthoisomers, para-isomers, meta-isomers. This is the problem. Substitution don't occur at the same carbon that has the leaving group. It will be happened, and the next also the other carbons. This is the problem. Okay, so a mixture of isomers, it will be formed. Also, this is the problem. A mixture of the isomers, it will be formed. So, if you go again, if you take this starting material, is what is metabromotoluene. This metabromotoluene, it will be react with NaH2, okay, and give you three isomers. 1, 2, 3. Okay, how these isomers can be formed by any mechanism? By any mechanism. This also the second, we say the second problems here. How this will be formed. Okay. The result rules out from substitution by addition mechanism. Yani addition mechanism cannot be answered how this product will be formed. Cannot be used here. Okay, this is the addition elimination mechanism. So we have to suggest another mechanism for this type of reaction is the elimination addition mechanism. Okay, is the elimination addition mechanism. So the mechanism that most consisted with the observation of this result of the isomers is the what? Is the elimination addition mechanism that outline in the next figure. I will give you the figure how the mechanism here it will be happen. So the first stage in this mechanism is the base promoted dehydrohalogenation. What meaning dehydrohalogenation? يعني minus here minus HX. Remove HX. Okay? Remove HX. Dehydrohalogenation. So of chloropenzene, put line here. This is the first step. أو مهمة. Okay? Put lines. أو مهمة. Dehydrohalogenation. The intermediate formed in this step contain a triple bond at aromatic ring أو بني triple bond أو شيء مهمة triple bond give you intermediate called what? Called benzene أو جديدة. It will be called benzene. Give you benzene intermediate. شو معنى benzene intermediate؟ يعني benzene ring has a triple bond. double triple bond. One excess pi bond. Okay, this is the benzene. أو benzene. Okay, give you benzene. So aromatic compound related to the benzene are known as arine. طبعا the same benzene arine or benzene arine. The triple bond in the benzene is somewhat different from the usual triple bond in the alkyne. They are different from the alkyne. Do you know the alkyl compound? Keep silent. This is the alkyne. For example, this triple bond alkyne. Okay, this triple bond is different from that found here in the benzene. Different properties, not the same, exactly the same, but different. Okay, so here is so reactive triple bond because this here is linear and here is restricted, yes, cyclic. So it will be here is more reactive triple bond in the benzene. Okay, the triple bond in the benzene is somewhat different from the usual triple bond that use it here in the alkene. So, first step, bedding. First step is the elimination stage. This is the first step, is the elimination, not addition. أول خطوة هي أول خطوة elimination. So amide anion is very strong base. This the amide anion is very strong base and brings about the dehydrohalogenation of the chloropenzene by abstracting a proton from the carbon adjacent to one of that pairs, the leaving group. So you have this leaving group. How many neighboring carbon you have? This neighboring carbon. Also you have this two neighboring carbon you have. Okay, two neighboring carbon. Yes. The NH2 maybe remove this proton or remove this proton. No different. You can remove this. Why no different? Because here we don't have any substituent. Okay, we don't have any substituent. But if you have like this compound, for example, we have CH3 at position number 2. For example, this chlor CH3, and we have here NH2 minus. Now, we have a proton here? Yes. No, there is no proton. No proton here. We have proton, one proton here. That meaning 100 by 100, the NH2 remove this proton. Okay? But here in this example, no, you can remove this proton or you can remove this proton. There is no difference. Both of them is the same. Okay? Both of them is the same. The product in the first step is unstable intermediate, is the benzene compound, benzene intermediate. شو معنى unstable؟ يعني more reactive intermediate. Active, so active intermediate. So, okay, the benzene طلبة is active intermediate. Active intermediate. Now, beginning of addition phase, it will be, we go to the stage number 2, the addition. Elimination, it will give you benzene, and here the addition. Amide ion act as a nucleophile, this amide nucleophile, and add to one of the carbon of the triple bond. Now this is the triple bond. How many carbon we have? This carbon and this carbon. That meaning NH2, it will be attack and this carbon or this carbon. Okay, here different. If the carbon attack from here is different to from here. If you have substituent here, okay? So it will be give you addition, and then we give you carb anion again. The carb anion, this again here as intermediate. Finally, the carb anion take a proton from the solvent. We have solvent, and it will be take a proton from the solvent and give you the final product. Okay, final product. That meaning our mechanism is what? Is elimination. Give you benzene and addition, followed by addition. I know. Okay, I will open the door. What's that? Okay. What's that? Okay. تمام. Now, because the ring prevent linearity of the, he said because why the benzene is active intermediate, not like alkyne. If you compare the benzene with the alkyne, why? If you compare this, and for example this, anyone is more reactive one, this or this? Of course, this is the more reactive one. Was reactivity come from the triple bond? A triple bond is different from this double bond. Triple bond. Why? Because the linearity of the CH3 in the alkyne unit, pi bonding in the unit is weak. Benzene is strained, يعني شدها, okay, strained and highly reactive. Okay, highly reactive intermediate. Homework. Keep silent. What? No. We talked about the reactivity of the triple bond. Okay? We talked about the reactivity of the triple bond. Okay, homework. This homework. He said 3-bromo 1,3-dimethylbenzene is inert to the nucleophilic aromatic substitution. Why? This compound 2 bromo 1,3 dimethyl benzene. This 1,3 CH3 CH3 Br. This compound is inert to the يعني خامل, cannot be entered to the reaction with the nucleophile substitution. Why? Because yes, because no neighboring proton. Our proton, there is no proton here. Also, there is no proton here, and cannot be give you benzene. Cannot be give you benzene intermediate. This an example. This an example. If you have this compound, give you benzene, and it will give you 2 isomers. If you have this compound, give you benzene, and it will give you 2 isomers. Now, here I will explain for you here. Look, meta chlorotoluene. Okay, meta chlorotoluene. This meta chlorotoluene. We have a proton here. Yes, we have a proton here. Yes. So, if the base remove this proton, give you triple bond here. Yes, give you this benzene. If the base remove the proton from here, give you triple bond here, give you this benzene. Okay, this 2 benzene, it will be formed with this intermediate. Now, second step, NH2 it will be add. NH2 if attack this carbon, give you this isomer. If NH2 attack this carbon, give you this isomer. Okay. Second benzene. If this NH2 attack this carbon, give you this isomer. If this NH2 attack this carbon, give you this isomer. That meaning we have 3 isomers formed from the reaction of metachlorotoluene with KNH2. We have 3 isomers. 1, 3 يعني at ortho substituent, ometa substituent, or para substituent. Okay. So why? Because the intermediate benzene that will be formed during this reaction. Also, the nucleophilic aromatic substitution by elimination addition mechanism is most commonly seen with very strong amide bases. It also occurs with the bases such as hydroxide anion. Also can be used hydroxide anion, but it's what? By using high temperature. By using high temperature. Okay? The substitution also can be happened. And there is many evidence. They replace the isotopes for the carbon by using carbon-13 isotopes. This event for the mechanism. 2. The homework. 2 isomeric phenol are obtained in comparing amount and hydrolysis of para-iodotoluene with 1 molar chia, 1 molar sodium hydroxide. At what? At high temperature. Which 2 isomers formed? This homework for you. Okay, why 2 isomers formed for you? This the homework. This the homework. Okay? Do you understand until here? Do you understand? Do you understand the difference between addition elimination mechanism and addition mechanism? In addition elimination mechanism, we have 2-step reaction. Step number 1, give you carbon ion. Carbon ion is stabilized by resonance. Or must be chia, must be you have withdrawing group. Step number 2, elimination step. And the second mechanism, elimination addition. Step number 1, elimination. From base, remove a proton. And give you what? Give you benzene intermediate. And then the base, it will be attack the benzene intermediate addition step. It will be give you final step to carbon ion, remove proton from the solvent, and give you the final product. Just this or this. So another type of reaction that we use benzene. Okay, what? Addition? But the question here, addition elimination must be there is an NO2 substituent. Yes, must be there is an NO2 substituent, or I give you 2 special reaction is substituted with multi-fluoride or halogens compound, or by using the pyridine compounds. Also, the pyridine compounds, it will be give special, special reactivity toward elimination. In addition elimination reaction. Okay. So now the final reaction that we use benzene as intermediate is the Diels-Alder reaction. Diels-Alder reaction. What meaning Diels-Alder reaction? What meaning Diels-Alder reaction, and how the reaction it will be? How the reaction will be happen with Diels-Alder reaction? Now, Diels-Alder reaction of benzene. You know what meaning benzene? Yes. Now you know what meaning benzene. How the benzene will be formed. Here in Diels-Alder reaction, he said there is alternative method for the generation that have made it possible to use the benzene as what? As an intermediate. Also, they use benzene as an intermediate. Okay, but from what? From the reaction of the aryl halide with what? With magnesium. If the aryl halide reacts with magnesium, give you what? Give you IR or RMGX. This is the Grignard reagent. Yes, of course. This is the Grignard reagent. So, one such method involves a treatment of the orthobromofluoropenzene. This is the orthobrom with magnesium. Usually in tetrahydrofuran. طبعا tetrahydrofuran or solvent. بس المهم ده magnesium. It will be react with this compound. So what do you think? Any bond is stronger than other? The carbon Br bond or the carbon fluor bond? Any bond is stronger than other? Nina electronegativity يعني. زين. Anyone is longer bond? Br carbon or fluor carbon? A brom, yes. Because the brom, the size of the brom is bigger than the fluor, that meaning the bond here, it will be longer. And the bond, it will be weaker. It will be weaker than the bond between the fluor and carbon. For this reason, the magnesium, it will be attack, and it between this carbon and this the Br. Give you complex is the ARMGX, give you the Grignard reagent. Okay, give you the Grignard reagent. The reaction proceeds by formation of the Grignard reagent from the orthobromobenzoate, since the reactivity of magnesium with the aryl halide, look, it will be chia, it will be ARI, and then ARBR, and then ARCl, and then AR fluor. Why? Because I said to you the same reason we said. Okay? So, if you have a brom iode, anyone it will be replaced. Yes, it will be react, the magnesium it will react with the iode. Okay? And give you the Grignard reagent. So, the Grignard reagent has the structure, this is the structure. The second one, next slide. عفوا؟ In this example, okay. In this example, reactivity Grignard reagent, the magnesium, to form the Grignard reagent is different from the substitution. I don't talk about the substitution. Okay, now we have complex. The magnesium will be react. Anyone is the more reactive one. Okay, if you don't understand, after the lecture. Okay, so close the mobile. Oh, okay, go. Now, look here. Again, we have this complex R. Grignard reagent R, Mg, X. Mg is positively charged or negatively charged? Again, positive. One positive or plus two? Good. Plus two. Two positive charges. That meaning this negative. Also this what? Negative. That meaning this alkyl. Alkyl. Okay. The same thing here. The same thing here. The AR here. The AR, for example, this Mg, مثلا Br. Okay. MgBr. Here is negatively charged. Positive. Positive. Negative. Okay, and here what you have? You have the leaving a group. Okay, if this negative charge make a triple bond, this leaves this structure and give you what? Give you benzene. Give you the benzene. Okay, give you the benzene. This is the idea. This is the idea. Now, benzene we said is active intermediate, and it will be react with the dienophile. What meaning the dienophile or the dienophile? What meaning the dienophile? Dienophile. What meaning the diene? Do you know what meaning the diene? Diene. If you have this compound, this methane, ethane, propane, butane, pentane. Tamam? Pentane. This is what? Alkene. Pentene, alkene. Okay. If you have double bond, diene. Okay? Diene. This is the meaning of diene. Dienophile, that meaning the benzene is love the dienophile, can be react with dienophile. Okay? Dienophile, that meaning love to the dienes. If you have benzene, directly the benzene can be react with the diene. For this reason, they say is the benzene is relatively good dienophile, can be react with dienophile. Can be react with dienophile. Yani can be react, sorry, with diene. Okay? So, and when the benzene is generated in the presence of conjugated diene, the benzene haya, okay, conjugated diene tahaya. What meaning conjugated diene? Yani double bond, yani double single, conjugated متعاقبة, okay? Conjugated diene. So if you have like this diene now, this diene double, single. If I write it like that, this conjugated diene? No, why? Because double, single. No, it is not conjugated. Okay? So just the conjugated diene can be used to this other reaction. Be careful here. Put here the conjugated diene وصل to 3 lines. Okay, is important notes here. The benzene, it will be react with the conjugated diene. So these are the cycloaddition can be occur, and it will be happened here. How the reaction will be happen here for this, if you want, I give you here an explanation, but okay. I go directly to the benzene intermediate, okay? This is the benzene. This is the benzene, okay? This is the benzene. Okay, where is our diene? For example, this diene. Okay, this diene. How the benzene it will be react with diene? Okay, look. This pi bond, this is the triple bond, pi bond, open and attack to this carbon. Give you a new bond here. It will be what? A new bond. What's up? A new bond. Okay? Now, a new bond. This pi bond, it will be converted to here. Okay? And this pi bond, it will be open to attack this carbon. Give you a new bond here. That meaning the product, it will be what? This is the product. This is the product. Look, this new bond, this new bond. Our new bond, our new bond. 1, 2, 3. 1, 2, 3. Tamam? Now, this is the cycloaddition. What means cycloaddition? The cyclization by addition. Addition the benzene to the diene. Diene, addition. It will be give you cyclization. Cycloaddition by the benzene. It will be add to the diene. Another example. Sorry. This we have good note. We have the pi bond. Yes, I forget. Okay, this is the pi bond. Okay. So another example. If you have benzene here, if you have benzene here, and this it will be react with the furan cycle. This is the furan cycle. Okay, this is the furan cycle. also conjugated double bond that has conjugated double bond. So what is the product? Huh? What is the? This the new bond, or this the new bond? Okay, write the product. This the benzene. Sorry, the benzene cycle. And this a new bond. This is the new bond, and we have oxygen here. Okay. This is the product. This is the product. Another example. Another example. Another example. Last one. This is the benzene react with cyclohexandiene. Okay. What is the product? Write the product. We have a new bond here. We have a new bond here. Okay. That meaning give you one, two, three, and a new bond, and we have 1, 2, 3. Okay, this and this, the same structure for this, nothing different. We have a bridged carbon-carbon bridge. Also, we have here carbon-carbon bridge, the same. This and this, the same structure. Okay. Just 1 minute. Belly conjugated. Double, single, double. Conjugated. No, okay. Not complete conjugated. مفروض طلب conjugated diene. يعني for this example, double, single, double. ما معنى double, single, double, single, double, single overall. No. Must be. يعني at least the double conjugated. Double, single, double. Enough. Not aromatic. For aromatic, it will be aromatic compound. If you have complete conjugated like that, there is no reaction because this aromatic compound is stable and there is no reaction can be happen between of them. So homework, this is the homework for you. I already resolved